Here we go again with another MLOps.community coffee session. We are in luck today because we've not only got Niall Murphy with us, the man who literally wrote the book on SRE, but we've also got David Aponte back from hibernation and Vishnu. It's the full crew today. I'm super stoked for all of you to be here with me and to talk about this idea and some of the crossovers that you have from being an SRE and bringing that into machine learning. So I think we should probably start, Niall, with that main idea. Like, what have you found over your journey that has been something, or some of the main things from going from this SRE background into the machine learning area? Like, how has that transition been for you?
Yeah, it's pretty interesting. I suppose the first thing I should say for your listeners is I actually ran a few machine learning SRE teams in my N-1th employer, Google, in the ads SRE space. So I have had, since I want to say 2013, 2014, some experience with the overlap between SRE and being responsible for machine learning production systems. But obviously, the Google context is not necessarily the context of the rest of the world or the average of the rest of the world or whatever. So not all of those lessons directly apply. But I think I'd characterize it in two ways, that many of the principles of SRE remain relatively unmodified in the presence of machine learning. I mean, you still need to care about the service. You still need to care enough to have threshold levels at which you react when things go badly, and you still need to be able to feed back information about how the system behaving in production should affect the design. Like, those constants in how, I suppose, responsible service stewardship should happen, like, they don't change under ML, but the details of how they happen, like, could change quite a lot. I think one thing in particular, there's lots of things we could talk about, but one thing in particular I'll surface right now. Some of your listeners may already have come across this thing called SLOs, service level objectives, which has both what I'll call an organizational component and a technical component. The organizational component basically amounts to people going, yes, we should probably decide what level of service the user should experience from our system, rather than implicitly assuming either 100%, which we can never achieve and damages an organization if all they do is react to try and get that 100%, or the level that it's running at right now, because that doesn't necessarily mean that that's the level it should run at or could run at, or all of those other questions. So that organizational component of getting an agreement, and also this technical component about what actual number we set that at, and how we measure that, what metrics we use, and so on. So SLOs, hugely important and kind of growing area of implementation for people who care about how they run their online services. The interesting thing in the ML context, SLOs in the SRE context have, I suppose, most simply been defined, or possibly even simplistically, depending on your point of view, but most simply been defined as you look at a metric for, a front-end, user-facing yarn store or bookshop or something, and you look at metrics like total failures or 404 return codes, and you count numbers and you go, well, the users probably shouldn't have more than 1 in 1,000 of these things fail, and so on and so forth. Now, it can get, even in the classic SLO world, it can get a little bit more complicated than that. Sometimes substantially more complicated when you get into applications like source code control systems, where the user journeys typically involve stitching together a bunch of underlying API calls, and you want to SLOify the user journey rather than the API calls in some sense. But anyway, in the world of ML, of course, you're not able to say, I want the users to have 1 in 1,000 of these recommender system calls fail. Because what does fail mean precisely in that case? Well, like if it's a classifier system, for example, there's usually some confidence kind of number associated with that. So I can confidently tell you this is a turtle or a rifle. But maybe actually this classifier system has been extended and it needs to recognize a turtle, a rifle, and a Bluetooth speaker, he said, picking something randomly, which was on his desk. And maybe the confidence of the system starts to degrade when it's classifying these things. And so you go from, let's say, a 0.8 average to a 0.5 average of return confidence of the system in each call. So so basically SLOs have to be extended to cover the peculiarities of the ML situation. Now, this doesn't mean we shouldn't have SLOs. This doesn't mean that we shouldn't discuss in depth, particularly with the business, what it means for these kinds of things. Of course, the business may not be always super interested in some of these details or regard them as being material to the customer experience. And I think that as an industry, if we move outside of the narrow scope of the systems that we're directly responsible for and the intuitions we have built up about the behavior of the systems within our purview, there's actually a fair bit of lack, certainly in the SRE community, about what it actually means to cross-compare these systems, to really have an idea of what good means. And as a result, I feel that SLOs and the question of monitoring production systems is still being developed science in the machine learning world.
I think you said so many good things there, especially on the topic of SLOs, of how they're more challenging, I guess, within the ML space because of some of the things that you mentioned. But I actually think they're really useful for finding like a way to communicate with different stakeholders. Like, for example, within the team that I'm working at, we use SLAs, or I guess that's like the level above that, to communicate what we expect from, let's say, a data source. So we can know that if we're going to do a bunch of feature engineering on this data source, it's not going to, have missing data every week. We're not going to have to raise ICMs after every time there's a missing row or something. And it's like coming up with a way to express what you expect out of a system. I think that's where they really are useful, as like a contract of sorts. I commit to this and I expect this, and I still think that they're really useful. Not that you were saying that they weren't, but I just wanted to comment and say that it's very challenging in my experience to come up with a way to capture the errors that you're trying to track, because there's many ones like you said, a failure or a missed API call or a 500, but they don't always tell us what's going on underneath that service, what exactly is going on with that model. And so there's these different layers. There's the infrastructure, which is a little bit easier to monitor and reason about using the precedent in the past. But then there's like what's going on underneath that infrastructure and how to really evaluate the quality of that when there's so many different moving parts, so many different interfaces. So in my opinion, SLOs and just like coming up with thinking about your machine learning work as a service of sorts, and what sort of quality and expectations you can our customers can expect from that. I think it's really useful.
Yeah, there's the analogy I like to use is often when you build a model and you start off with things being Booleans, right? Okay, this behavior, we either totally see it or we totally don't see it. And then after a bit of time and exploration and so on, you go, actually, this probably isn't a Boolean, seems a bit more like a real number, might occasionally have irrationals in it, like that kind of developing of detail. And it's a bit like when you move from the understanding of dimension as being an integer towards being a potentially fractional or real number quality, as happens with fractals and other related mathematical constructs.
So, Niall, one of the things that I wanted to ask you about, given your depth of experience in SRE, is really at what point organizations start to invest in SRE and might expect to add members of their team that have those kinds of skills. I think a lot of machine learning organizations start off, as we talk about on this podcast a lot, with either a machine learning professional or a software engineer turned machine learning engineer. At what point does the SRE expertise need to be infused? And how does that process tend to evolve?
Yep. Great question. I think in order for me to retain some clarity in this domain, because it's a very complicated question, I think questions like when should we hire our first SRE tend to bring in concerns about, can the company afford it? What's the skill set? What's the interviewing process look like? All of those are hugely complicated questions. I'm going to pair off that complexity and say, what behaviors do you need from the people on the team in order to have a well-running service? And I would argue, personally speaking, that the behavior of being production aware or production oriented, depending on how you put it, right, should start like quite early on, because the earlier you start it, the cheaper it's going to be. I mean, organizationally, not necessarily money, but also money sometimes. The cheaper it's going to be to have a system which will scale, develop, be easily observed, monitored, you know what the hell's going on, all of those great qualities. You actually want those qualities, I would argue, for more or less any service. So even if you're one developer, having some kind of production exposure is a good idea. But I suppose historically speaking, it would have been perceived that you only need this when when and a separate role, a separate person or team kind of dedicated to this kind of work when you get above a certain size. I don't know about that. I think the thing I'd say is I would be service geared or user experience geared about this rather than total suite population is like 1,000. We should probably scatter a few SREs around here. That feels a bit more imprecise to me. So from a behaviors point of view, I mean, the interesting thing about not being production minded for a long while is that you don't necessarily know what's going on with your service. And if you happen to be making, X amount of money, and you could be making 2X because various systems are failing or not recommending things, et cetera, it's difficult to discover that unless you have already taken the actions which would cause you not to be earning 1/2X or whatever, right? So coming back to try and answer your actual question, I would say that you don't need to hire an SRE at any particular point as such, but you do need production mindedness. And the historical ratio that was used in Google is about 10%, like 5 to 10%. Of engineering effort, for want of a better word. I think that's a number you would modify depending on the particularities of your situation. And I don't necessarily mean kind of organizational backing or money or anything like that. But for example, if your infrastructure delivers you 3 nines without doing anything, like if you just launch the jobs and they're 3 nines without much effort, well, you can probably continue for quite a while under that setting. If, on the other hand, you launch the jobs and you can't even muster a 9, well, you probably need some kind of concentration expertise. And this kind of feeds into one of the origin stories of SRE in Google, which is close to the very start when there's 50 engineers or something like that. And a subset of the engineers decide that they care about, or they kind of self-select that they care about the production performance of the product. By the way, at this stage, there's only one product, like the search engine. And they start doing things like asking questions, this index hasn't been rebuilt for like 3 months. Maybe we should do something about that. And those kinds of questions and concerns, often across a sufficiently large population of engineers, you will statistically find some people who care about this kind of stuff. And that's definitely what happened in the initial Google case, folks who self-selected, and they ended up turning into, I suppose, an SRE team, or at least that's an origin story you can tell. So probably if your organization is sufficiently large, like in the tens or whatever, you can statistically find some people who care about that. And in fact, they're probably keeping the whole thing going right now, and you don't necessarily know it.
I really, really, really love that answer. The whole behavior of teams concept. And I think one of the things that really resonates with me in that answer that you didn't say, but I kind of learned from it, is that if you think about your team not just as a composition of skills, but as engaging in a set of behaviors, you can take advantage of the people who may not necessarily, look like an SRE or look like a platform engineer or even look like a machine learning engineer, but are engaging in those behaviors, and you can let them continue to do that, right? Let those people who self-select into those roles continue to grow and really grow with the organization. I really, really love that perspective. I think David felt similarly, so I'm going to kick it to him.
Yeah, I just want to say that's actually how I kind of got into the MLOps space. I started my journey in this industry as a data scientist, mostly focused on the model development, being a kind of researcher. And the way I thought of myself was a problem solver. But I got more and more interested in, okay, once I built something and I have to get it out there, I saw that it was so hard to do that. And there was not a lot of, I guess, information out there to help you and guide you with that, specifically within the MLOps space. And so the more I started searching, the more I started caring about that. And like you said, I kind of self-selected to really focus on those things. And naturally, that's kind of how as the space that you heard that buzzword MLOps coming out more, it's like, oh, okay. But I thought that was so cool how you said that, because I've seen that experience even amongst other engineers. Some people just naturally care about their system being reliable and robust, either because they're lazy and they don't want to wake up to any 2 a.m. calls, or they just genuinely that's what they're focused on. Some people are more focused on the development side of things, pushing the boundaries and trying new ideas out. And I think it's good to, if I was a manager, I would try to pay attention for those things, and I would try to see if I can cultivate those skills further, rather than kind of pigeonholing them to just one title, because oftentimes a title can kind of veer into different skills or workloads. But yeah,
lazy like a fox, as they used to say about Linus Torvalds. I think the nice thing about keeping it informal is you retain kind of greater equity in the team for a longer time. But the nice thing about having an explicit team for it, and I suppose at some stage titles and so on and so forth, is there's more kind of formal support and recognition. And actually, sometimes that's worth quite a bit as well. So,
I think, that's actually a really good point, because I feel like in the MLOps space, that's actually one of the challenges is there's a lot, like more often than not, people are looking elsewhere besides their own organization to learn about how to deal with machine learning in production. They're learning from all the blogs, all the articles, and it's just hard to teach people these things when your own company is still figuring those things out. And so they look elsewhere. And I think you're exactly right. If there was a team with a dedicated set of expertise that you can kind of inherit and pass on, I'm sure that would make things go a lot smoother. So maybe that's like a little hint in the future. You'll see like MLOps teams kind of developing or cultivating these titles with these set of practices and passing that down throughout the organization.
And I think that's a good segue into me asking the question to Niall about the book that you are writing with Todd Underwood, who we've had on here. And I heard rumors that D. Scully is also going to have a few pages in it too. So we're all dying to see this thing. I know I talked to Todd a few months back, and he mentioned that tentatively it was scheduled for August, but then it got pushed back. And so I'd love to hear an update.
Yep. The book in question, he said, putting on his best shilling hat, is called Reliable Machine Learning and is now due in January of next year, if I recall correctly. We're about halfway done. We have cooperated with a number of folks on the MLOps, in the MLOps community and on the Slack in particular. And so great thanks to everyone here for facilitating that, because it's been a fantastic resource to connect. I think, David, your point about people looking outside of their organization, first of all, to learn is totally on the money. And it has every benefit and drawback of that approach that you could imagine, which is to say, oh yeah, like it's relatively easy to find loads of people who have this thing, but maybe relatively hard to find somebody who is as motivated as I am to solve my particular problems, right? But anyway, sorry, I let my shilling hand drop on the floor. The reliable machine learning book is out early next year. We are about halfway done. D. Scully is involved. It's myself, Todd, a gentleman by the name of Kranti Parisa, and Kathy Chen are the current authors. We've also had folks contributing to chapters, both reviewing and writing from the Slack, and also other contacts, etc. I have enjoyed the experience greatly, although I have also had the same reaction every time I've previously written a book, which is, oh my God, I will never do this again. And it's kind of like what they say apparently about having a baby, which is you go, yes, I'll have this baby. You have the baby, you go, I'm never doing that again. And then a couple of years later, you forget, and then you have another baby. And then you go, I'm never doing that again, and so on and so forth. So for books, I have enjoyed, because I often learn about things by writing about them, which is kind of a slightly weird casting, I suppose. But
the Feynman method in many ways, right?
Yeah, exactly. So I've learned a lot in the writing and construction of this book, and I have also not learned a lot, in the sense that many of the things I've learned I've either relearned, or the parallels with the other stuff I'm doing in the SRE space have been very strong. So I think one of the things which has notably kind of struck me is when I look at the industry and what folks are doing with ML platforms and with kind of ad hoc ML stuff, I don't want to use the phrase Wild West, because that implies, I suppose, lots of people shooting each other in Main Street and stuff like that. But I think there's a frontier air to what's going on. And if you are not successful at reaching outside of the organization in order to find templates for how to proceed, you kind of make stuff up. Or like the previous engineer who was looking at that left something in their home directory. You should copy and paste that, and so on and so forth, right? So it's frontier's land, and that's on the one hand tremendously attractive, because it means that coming in and writing something and so on, you get to put your stamp on what's going on. On the other hand, if what you're looking for is extremely well developed rigor, like that is not present right now, I think is how I would put it.
So I've seen some questions that you've had in Slack, and I get the feeling in this book you're probably writing a page or two around monitoring and how monitoring for an SRE differs from machine learning, I would imagine. Can you explain that a little bit more?
Yep. So I think the fundamental kind of high level point is that SREs really understand and use the term monitoring in a different way than, I suppose, the average ML engineer or data scientist or whatever, who are often focused on model development. And I don't mean full lifecycle model ownership, I mean model development. And there's a golden set of data, and there's some tweaks and refinements and so on and so forth. And I find that context where the idea of metrics or KPIs or things in that space are very well understood by data scientists. But the thing that SREs understand that data scientists don't necessarily is that whole life cycle approaches and having as much visibility as you can, including operating in production now. For various technical reasons, that isn't always possible, et cetera. But as much visibility as you possibly can for the whole life cycle is actually crucially important to figuring out what's going on. And I'll put a little asterisk there that we'll get back to in a moment. But the thing that data scientists understand that SREs don't necessarily understand is, well, like they have a PhD in statistics, or there are elements to the subtleties of how systems react, or how ML systems react, how training works, and in particular, the classic distinction between ML and more or less everything else, but certainly classic SRE work, which is that the data matters. And it matters in a very real and subtle way to do with distributions, to do with availability, to do with flow. Like all of these concerns are not necessarily kind of classic SRE concerns.
I think one more thing that I also a difference is that SREs tend to think in systems. They think about engineering not just one component but an entire system, and so more often than not they're thinking about the different interfaces and how each one plays with each other. And that may be more, I guess, they may be monitoring more than just, let's say, the model, right? They may be monitoring the data, the service that's serving the data, the network itself, access patterns. Like there's all these different things that may not be important to a data scientist, right? Nevertheless, makes their work possible. So I think there's a subset of like the concerns that really like is important to a data scientist, right? The availability of their service, some basic infrastructure things, but then it gets a little bit deeper, right? They have different questions that an SRE may not be thinking about. And I don't think that necessarily means that they can't work together. It's just they have, I guess, a different set of skills or questions that they're thinking about. And it's learning how to get the best of both is what I'm trying to kind of learn and mix together, but it's challenging.
Yeah, I think one of the ways I have historically put this is so much about the modern profession of software engineering in general is the question of what can you successfully ignore? And so many, a lot of organizations go, okay, we're going to create a team to do this, which means we will ignore this other thing. We will hire people with this title, which means we will focus on this and therefore ignore this other thing. But also the very idea of, we'll say, siloized teams and kind of throwing the model over the wall is very like how development and operations hard splits would have happened, certainly in the past. Obviously, that model is being challenged by DevOps, SRE, and a bunch of other stuff. But all of these splits are about, okay, in order to make progress, I need to ignore the things to the left of me and to the right of me. And actually, one of the big realizations, I suppose, across the industry, at least from my point of view, would have been, oh, actually, maybe we can't successfully ignore those things. Maybe what we need in order to be more successful is to have a holistic approach and to have more awareness of what's going on in the whole lifecycle management. Now, obviously, that has a cost. It has a cost to the individuals, maybe to the organization, so on and so forth. But when I have seen flow in a team work best in the past has been when it hasn't been the sum of a bunch of finely chopped up teams with very fixed responsibilities. It's been fluidity. It's been awareness of the overall set of responsibilities and people stepping up to the plate when that's been important, and so on and so forth. I had an asterisk a while ago, which I think actually might illustrate this point perfectly, which is the question of incident response in machine learning. So incident response in machine learning is hugely complex. And part of the reason why it's hugely complex is because ML pulls in so many more components of the overall business than, we'll say, classic systems usually do, that ML incident response often involves researching whether or not the price of yarn has changed on the world commodity markets in the past week, such that your supplier can no longer supply the particular thing that you need, which results in over purchase of this thing or under purchase of this other thing. Investigating those issues are often questions of days or weeks, and not things which are resolved in the 2 hours, which is basically the median time in which incidents are resolved in, we'll say, cloud providers and cloud consumers, and more or less anything with scale.
I just wanted to kind of piggyback on something you brought up with respect to incident response for machine learning. I'm actually thinking about that right now in my job, where we're trying to think of coming up with a separate on-call process for the data science team. And just to preface why that's even necessary is we have our own on-call process where a lot of data engineers and software engineers they have their rotations. They know how to deal with these different pipelines that are broken. We have our own incident response management system. But now that we're going to be getting more models being, as a part of that system, let's say when, I don't know, the latency gets like over 30 seconds or something, an alert is created, or a certain amount of failures create a ticket or something. And we need to think about, okay, this on-call engineer, maybe they're a data engineer, a software engineer, they may not have the know-how to truly debug this service. Maybe they could restart a job or rerun something, but if they need to go in and, really evaluate the quality of this model, they may need some help from a data scientist, someone who either built that, someone who better understands the statistical nature of the inputs and the outputs. And I find that that's like kind of the challenge I'm thinking about. Like, the first step that we took was to create, troubleshooting guides. But I'm sure, as we all know, that gets old quick because you have to keep them up to date, and maybe it doesn't have enough detail. And so we're reasoning through these different things. I wanted to hear your thoughts on that. Like what has been your experience working with hearing from other people how they deal with their on-call for machine learning? Is it that different from the normal traditional on-call rotation for, let's say, a web service or some API? Or should it be different enough that, for example, there's maybe not a different set of practices, but a different way of working? Like, so one example I thought of was we have a software engineer as the primary, maybe a data scientist as the backup. So, we're recovering both bases or something. But again, maybe that doesn't work. So I'm just like trying to think through like how are organizations doing that? How are they coming up with an on-call process specifically for machine learning in production?
Yeah, great question. I can tell you two possible approaches. The first one is what Google was doing in kind of the 2015 plus or minus 2 era, which is to decide that the peculiarities of the ML situation, particularly when it came to very complicated kind of production resolution things, was impractical to expect an SRE team, even one composed of a bunch of PhDs in statistics, to actually master in a useful period of time. And so what they did is help to create a situation where A, it's kind of more expected to escalate, B, the time that you have to respond, and this is actually a crucial point, the time you have to respond is much larger because model degradation generally happens on a much larger timescale than a web service going down. So it's both less immediately urgent to respond, and you might not have all of the skills to respond usefully. So the thing that matters is second item, creating what's called a big red button, a fixed, relatively context-free mechanism that you can just mash heavily with your hand and have that do something useful in production. This almost always means model rollback. And obviously in the Google internal production system, rollback and so on is relatively well understood operation. This is not the case everywhere, but that's why it's good to pay attention to constructing a software-based, you can turn it into a hardware-based big red button if you wanted, and I'm sure people have, but basically something you can press which will revert back quickly or known good state quickly. Now, of course, ML is complicated, the world is complicated. Sometimes model reversion doesn't work. In the classic SRE space, we would often say that rollback of some kind, when accompanied by a schema change, is tricky because the software expects the columns to be in a particular format, and the columns are not in a particular format, and you cannot copy the...
That's happened to me. That's happened to me not too long ago, actually.
Okay, so if rollback is not possible and you find yourself doing roll forward, well, okay, now your build process has to be big red buttonable, which is to say I need to mash the emergency button and have something built as soon as possible, which built from head or whatever, or cherry picked, which can be rolled out in production with the new schema and work well and so on. So those are really the approaches I have seen. Are there other potential approaches? I suspect so.
Whether or not to learn.
Yeah, right.
we're gonna have to wait till your book comes out, and then that's gonna also help too. But no, like I think just want to follow up on what you said about rollbacks. Like, yeah, these are, in my opinion, these are basic SRE things, or maybe not basic, but these are things that have been done for a long time in production, and that's what I'm going back to what we said at the beginning. It was just like, I end up trying to find the differences between these two fields, SRE and MLOps, but more often than not, I end up going back to the basics, these old things, and applying them to the new things. And I struggle with that sometimes because I know that they're not the same. That's why I'm struggling with literally just copying and pasting or directly applying it. But they're not so different that I can't use them. And I'm just, I guess that's one of the things I like to do is synthesize this information. But sorry, go ahead. The guys want to say something. Go ahead.
Yeah. I totally feel your pain there, David, with trying to figure out, how to cross apply basics. It's a pretty important, I think, maturity thing as an engineer, figuring out how to do that. Niall, one of the things that I think has been interesting about this conversation has been your allusion to how SRE evolved at Google. You spent some time there, and your experiences at Microsoft, and how you had lessons to sort of learn, and how that informed how you ultimately ended up managing MLOps. I'm kind of curious if you could give us a bird's eye perspective, though. Kind of zooming out. You were at Google for, I think, double-digit number of years, 11 years, and then at sort of global head of software engineering for Azure, related to SRE. How did you see the machine learning burden grow over time? In terms of posing a separate set of problems as opposed to the other, fields of software engineering with cloud issues and web service issues and all these other things. And how did you manage that, kind of at a high level?
Yeah, very interesting question. I mean, it would be hard to disentangle my answer to this question from the cultural differences of the gigantic institutions in question, right? And to a certain extent, that might be doing a disservice to the listeners. I mean, not all of them will be working in 130,000 employee companies or whatever it is. But I think the highest level things I could usefully say are that from a cultural point of view, Google's kind of a company, or was at least anyway. I mean, they all change and they all evolve over time. And I'm out of Google like 3.5, 4 years now. But Google was a company of systems and rules in some sense. If what you wanted to do could be achieved as kind of a linear combination of things that were already around or available, or could be kind of linearly extended from a system that you had, good stuff. You could more or less do that without having to talk to anyone, I mean, for sufficiently small scope stuff. Microsoft is a company of humans. You can't do anything without talking to the humans, and it's kind of a very, I suppose, neurotypical culture in that sense, or extrovert culture, or however you would put that. So the ML ops space was kind of treated pretty differently in both companies as a consequence of that culture difference. And I'll leave to one side the question of the industry overall for a moment to come back to it. But the culture is really, ML is growing in both companies very, very strongly, more or less. I won't say every business leader sees it as magic pixie dust that they can sprinkle on things to make 20% more money, but a lot of them see it that way. And so they're going around sprinkling it on everything. But the MLOps challenge would be a centralized response in Google composed of a linear extension of a bunch of already existing behaviors which are well understood. We'll extend the SLO metaphor. We will create a separate team, centralized team for ML, etc. In the Microsoft context, it's every business unit does what they see as most appropriate for the challenge of their customer relationship at that particular time. And so there's comparatively little standardization, or a number of folks are reaching outside the company to find what to do rather than inside the company. So much more diverse set of responses, but also, I suppose, arguably quicker in the sense of kind of responding more immediately to customer needs. And so that's how I've seen the cultural bit play out. The industry bit is kind of a separate question, because I mean, coming back to the point that we're going to sprinkle this ML pixie dust on more or less everything that moves, and even a few things that don't, just see, that is creating a massive challenge for MLOps folks who haven't been at the sharp end of a massive scale up before, right? So if you were lucky enough to be in some of the hockey stick companies at the right time, you know what it's like to have, as happened to me in the first couple of years in Google, the system that I was looking after each quarter did more work than the sum of all of the previous quarters. And in that kind of environment, you go, like, there are immense challenges with respect to what you do and how you, if you have a subcomponent of the work that scales relatively linearly as a function of how your customer base grows or how your inputs, organizational inputs in some sense, grow, then you're kind of stuffed unless you grow the team size linearly as well, which is in itself problematic. So you need to put, if nothing else, the strong awareness of systems and scaling via software and removing toil and all of those kind of SRE metaphors for actually managing this thing takes me ON input or some function of ON input, where input is the number of customers or number of models I have to manage, or complexity of the models that I need to manage, or data size that I train over. Like, all of these things are growing massively. And in some sense, that's what the ML platform companies that I see out there today are promising. Like, we'll get rid of all of this for you. Yeah, well, you won't get rid of it as such. You'll tidy it away in certain ways, and sometimes you can successfully ignore the things that have been tidied away, but sometimes you can't. So I see the challenge, to come back to your question, as really being a function of scale and of processes and standards that aren't there in the frontiers land that we're occupying at the moment.
Super interesting, Niall. I think that a lot of what you said highlights the humanness of our industry and how that's a huge factor. It's not just like technical things. You're dealing about processes and people working well together. Kind of to finish off, I have two questions. One is, how did you get into this space? What made you so interested in thinking about these sorts of problems? And secondly, what did you do to develop yourself to have the, there's lots of different disciplines that kind of come up, right? Engineering, which can be not just software engineering, but civil engineering. You got computer science. There's lots of things going on here. And like we were kind of bringing up earlier, I often go to the basics, but what does someone like yourself do to, especially as you were kind of early in like this MLOps space as things were happening, what did you focus on? And I guess, yeah, so the first question is, how did you get interested in this space? And secondly, what did you decide to focus on as you were developing yourself in this space?
So there's two kind of answers to that, possibly quite different answers, depending on whether or not you care most about ML ops or software and ops in general, or both. So I think if I were to start off with the generic answer first of all, I would say, so I'm the child of a single mother in Ireland in the 1970s, when there wasn't much around for anyone except a bunch of books and every so often interesting shows on television. And I imprinted on this show you may have heard of called Doctor Who. And in the 70s, at the age I was, the impressionable age, Doctor Who and questions of time and space and physics and travel and adventure and so on, in my mind, very strongly associated with science fiction and computers. And I suppose relatively early on, I kind of said, all right, I'm going to do something in computers, and I don't know if it's going to be my full-time thing or not. Anyway, I ended up choosing computers. How I ended up choosing operations in general is a slightly more complicated thing, but I suppose one answer to it is I got into university in the early 90s. Oh my God, that dates me. And I discovered, looking good. I discovered to my horror that students were not given internet access by default by the institution I was in, University College Dublin. And I said, this is terrible, we've got to fix this. So I got together a student society and we built a Pentium 90 with 32 megs of RAM and gave internet access to 2,500 students with a kind of system administration committee and a bunch of other stuff. And I think it's still going today, actually, even
Awesome.
though computing services in the college essentially allowed the undergrads to do their work for them for like 10 years or thereabouts. Anyway, I got interested in software and operations in that way. And then I suppose I got interested in machine learning in the Google context when at short notice, half a day, if I remember correctly, I was asked to take on management of a team. One of those managerial experiences I will never forget. And that began my journey. That's where I met Todd Underwood. That's where I ended up learning a lot about how this crazy thing works. And yeah, that's my journey.
I love that. Thank you so much for prefacing it with your love of Doctor Who and some of the inspiration, because honestly, that is, I'm very similar in that regard, where it's these kind of non-technical smart things that inspire me, good stories, good fiction. But yeah, thank you so much for that.
No worries.
So sadly, I think we have hit the time barrier. And I just want to make sure that everyone out there knows, Niall, you're in our Slack. You also have a book out already. So if people want to go deeper on this SRE topic, we will link to your book below. And as we mentioned before, a new book is coming, hopefully at the beginning of 2022. That's what it's slated for right now. We're all kind of foaming at the mouth to look at that. Maybe I tried to ask Todd this, if we can get some early revision and pass it around the community, or at least pass it around the three people that are on this call right now. But very selfish of me. But yeah, we're all super excited for that. And we love what you're doing. Can't wait to see all of the different yarn examples, because I know there are going to be a ton of different threading and yarning examples in that book. I've heard you and Todd talk about it as your go-to metaphor or example. And that's it. This has been awesome, man. Thank you so much for coming on here. I think Vishnu and David also are echoing that sentiment. This was super useful.
Yeah, thank you so much, Niall.
Thank you very much. And thank you to everyone who helped me on my journey listening to this.